Hello, guys. Welcome to our first class of advanced geometry. I'm your teacher Simon, and let's start. First, brief introduction of our class. So the class time will be every Monday from 8 p.m. to 9 p.m. And after 9 p.m., we will have a half-hour Q&A session. So if you have questions regarding the material or regarding the assignment, you're welcome to stay and ask questions. And each week or after each class, there will be a short assignment based on what we learn in the class. So usually it's just a small assignment. It usually contains about 5 to 6 questions. We have multiple choice questions or just filling on the blank. Just simple one. Okay. Um, any questions regarding this part? Okay. Let's move on. Okay. I will first start with perimeter and area. Okay, this part is definitely, of course, you guys already learned, right? We have perimeter, we have area. Okay, for triangle, okay, the perimeter is we just do the sum of all the three sides, right? Take a look at the first triangle here. Let's mark A, B, C here. So to calculate the perimeter, you just do the sum of all the three sides. And if you want to calculate the area of a triangle, okay, we're using 1/2 times the base times the height. Okay, that's the formula, right? That's already know. Okay, that's too simple. Okay, now, what about this? So imagine let me just draw two parallel lines. Okay, L1 and, hold on, L2. Okay, the L1 is parallel to L2. Okay, two lines are parallel. Now, if I have a fixed base on the second line, let's mark a B point here. Now, in order to form a triangle, we need a third vertex, right? You only have two, and I will call the AB. We always have the base AB. Now, if I want to form a triangle, let me take a point on L1 mark D here. Okay. And we connect AD and we connect BD. Okay. This is a triangle. And if I'm telling you the area for this ABD is, let's say it's 6. Now, my question is, what about this one? Let's mark this point as E here. Okay. What about the area of triangle ABE here? Okay. All the information we have right now is the area of triangle ABD is 6. Okay. Now my question is, what about EAB here? Okay. Will be still 6, right? And the reason is they share the common base and the height will always be the same, right? The height is basically the distance between the line one and the line two, right? It's just the distance. Okay, now you can also form another triangle here. All the triangles, the area will always be the same as long as we have two parallel lines and we fix a base. Okay, no matter which point you take on L1, all the triangles, the area will be the same. Okay, now, right now, we always use, okay, now the height is given, the base is given. Okay, now you will say, okay, definitely you can calculate the area, right? So what about all the things we know is not like just the base and the height, and you calculate the area. It's that simple. What about we only know the side? For example, okay, just draw any triangles. All the information we have is, for example, 4, 4 and 5. Okay. Now the triangle here is isosceles triangle, and two sides are 4, and the other one is 5. Now I'm asking, so can you calculate the area of this one? Or even though, okay, not isosceles, just 4, 5, and 6. How do we calculate? Is we can apply the Heron's formula. Okay, what we do here is first we do the sum of all the three sides. Takes a 4, 5, and 6. Okay, as example, what we do here is let's say A is 4, B is 5, C is 6. 4, 5, and 6. That's the length of the three sides. Okay, now S will be equal to 1 over 2 times 4 plus 5 plus 6. Okay, and 4 plus 5 plus 6 will be 15, right? 15 over 2. That's the S. Okay, now look at the formula here. We have is we take the square root of 15 over 2 times S minus A is 15 over 2 minus 4 is 7 over 2, right? And S minus B is 15 over 2 minus B is 5 here is equal to uh, 5 over 2. And the last one, S minus C, is 15 over 2 minus C is 6. Okay, 3 over 2. So we are actually doing 15 over 2 times 7 over 2 times 5 over 2 times 3 over 2. Okay, now after you calculate this one, the answer will be the area of any triangles as long as the three sides are given. Okay, now you may ask, how can you prove this is correct? So why don't we make it simple? So we're actually using a right triangle. Okay, we mark as A, B, and C here. And the corresponding side will be A is equal to 3, B equal to 4, C equal to 5. Okay, now, based on the Heron's formula, the first things we do is we do the sum of all the three sides. 3 plus 4 plus 5 divided by 2. This is very important. You are not calculating the average of A, B, and C. You are do the sum of A, B, and C, and you divide by 2, not 3. Okay, and this one is equal to 3 plus 4 is 7, 7 plus 5 is 12 over 2 is equal to 6. Okay, S equal to 6, A equal to 3, B equal to 4, C equal to 5. So you're actually using S times the difference between S and A and times the difference between S and B and times the difference between S and C. Okay, equal to 6 times the difference between S and A is 3. S and B will be 2. S and C will be 1. Right? Okay. What do we have inside the square root will be 6 times 6. Right? Square root of 36 will be basically equal to 6. Okay. This is we're using the Heron's formula to calculate the area of this right triangle. Okay. Now, what about we directly using the base times the height divided by 2? It's 1 over 2 times, this is already a right triangle, so we times the base times the height. Okay, 12 over 2 is equal to 6, right? It's the same. Okay, so actually prove this is correct. Okay. Any question regarding this part? Okay, you may say, for this right triangle, we can directly do like 3 times 4 divided by 2. It's 12 divided by 2 will be 6. We directly get area. Why do you using such like sophisticated formula? Is because this one is right triangle. So what about I change the side? Instead of using 3, 4, and 5, I using 3, 4, and 6. Okay, now it's not a triangle, it's not a right triangle, it's not a spatial triangle. It's hard to directly calculate the area. But in this one, you can still calculate the area. Okay, any questions? Okay, if not, why don't we do a small practice? I will put the formula here. Oh, no, divided by 2. And area equal to square root of s times s minus a, s minus b, s minus c. Okay, why don't we do a small practice? Okay, I just issue the pop survey here. So if you got the answers, you can just select the choice. Okay. We have we have B choice, we have E choice. Okay. Now for this one, first three sides length is given, right? Are given. It's 21, 28, and 35. Okay. So first, it's not like the normal spatial right angles like 3, 4, and 5. So all the three sides are 21, 28, 35. So what do we need to do? The first step is we calculate the S is equal to 21 plus 25 plus 35 divided by 2. Okay. 21 plus 28 plus 35 is 84. Divided by 2 is 42. Okay, that's the S. Okay, now what do we need to do here? Area is equal to square root of S times the difference between S and A, right? 42 minus 21, 42 minus 28, 42 minus 35, right? And this one is equal to square root of 42 times 21 times, this is 14, this is 7, right? Okay. And if you actually calculate the inside values, so this one is actually equal to 294. Okay. And we will choose E for the right choice. Okay. And also, there's a second method for this one is, okay, if you do 21 squared plus 28 squared, okay, if you do the square, Do the sum of the square for two sides. It's actually equal to 35 square. So this one, this triangle is actually a right triangle, right? So we can directly do, okay, 1 over 2 times 21 times 28. You can also get the values. This is a 14 and 294. The right answer for this one. Okay, that's the first one. Okay, let's do another one. Uh, this one. Now the three sides up. Let me just put C. Area equal to S times S minus A, S minus B, S minus C. Okay, very good. This one. If we want to apply the Harris formula, what we do here is we first calculate the perimeter divided by 2. So 5 plus 12 plus 13 divided by 2. This is a 30 divided by 2, right? Equal to 15. Okay. And the second step is just plug into the formula, right? S 15 times 10 times 3 times 2, right? So it's square root of 150 times 6, right? It's actually square root of 900. Okay, 900 is actually 30 square. So this one is actually equal to 30. Okay, and also take a look at the three numbers here. So it's 5 square plus 12 square is equal to 25 plus 144, right? It's equal to 169. 169 is actually 13 square. So this one is also a right triangle. 5, 12, 13. But you can still get answers by using the Harris formula. Okay. Uh, any questions? Okay. Uh, I just gave the right triangle here to prove what we did here is correct. So it's not always right triangles, even though it's if the given information is 5, 10, and 12, it's still you can use the Harris formula to get answers. Okay, that's for sure. Okay, now let's continue. Now, this is one part. So just for one triangle, we can calculate the perimeter, we can calculate the area. So using different method. I just do not draw. Okay. So, but what about we have two? Okay. And the most common thing will be similar triangles. So what is similar triangles is two triangles are similar if their corresponding angles are equal and their corresponding sides are proportional. In simple word will be uh, the shape will be the same. The only difference will be the sides, right? That's the similar triangles. The definition of similar triangles. Okay, and okay, any question with similar triangle or all the things we have already talked about? Okay. Okay. Now, before we talk anything different, let's first talk about, okay, how do we prove or how do we know two triangles are similar? Okay. The first thing is angles. Okay. According to the definition, all the three angles are the same. All the three corresponding angles are the same. Then we can say, okay, those two triangles are similar because the shape will definitely be determined. So the only difference will be the sides. Look at the triangle ABC and DEF here. Okay, now the thing here is, do we actually need to prove all the three angles are the same? Actually, it's not, right? Because we know the sum of the three angles, three interior angles, would be 180 degrees, right? So if two angles are already given, the angles are already given, like B here is 50 degrees, C here is 50 degrees, then there's only one possible values for angle A. So we do not need to prove all the three angles are the same. We can actually see, okay, if two corresponding angles are the same, then the two triangles are similar. Okay, and if you take a look at this picture, okay, because the third angles must be equal automatically, right? So we only need two angles be the same. Let's take a look at this graph. So find any similar triangles in the picture. Okay, why don't we take the large one first, the triangle BAC. Oh, okay, that's the largest triangles in the graph. Okay, which one is similar to this one? Okay, BAC. This is a right triangle, right? So look at the, let me just color here. The green triangle, BCD here. Those two will be similar. And why is that? Because first, they're both right triangles. So one angle will be 90 degrees, right? This one is 90 degrees. For the large BAC, this one is also 90 degrees. Okay, so actually, they also share the common angle B here. So those two are similar. And we can also add one more triangle here. It's actually the top right triangle here. Okay, this is triangle CAD here because it's also right triangles and they also share a common angle A here. Okay, this one definitely you have already learned about this one. Okay, what if we know? Take a look at the first two triangles. If we already proved those two triangles are similar, because all the three angles, let's see, just the two angles, two corresponding angles are the same. We actually prove those two triangles are similar. Once you prove those two triangles are similar, the corresponding side, the ratios will be the same. BA over BC is equal to BC over BD is equal to AC over CD, right? That's a definition of similar triangles, right? The corresponding side are proportional. Okay. Okay. Why don't we do a small practice regarding this one? Hold on. This part. Uh, Let me just issue the. This one. Okay, for this one. First, we need to find which two triangles are similar, right? So the given information is CE is parallel to BD here. So we have angle C is equal to angle D. And this angle A is equal to angle B here. Okay, so what we can write here is triangle CAE. Okay, first take C, then take A, then take E. Will be similar to triangle first take B, then take D, and then take B, and then take E. Those two triangles are similar, right? The order matters. And once you prove two triangles are similar, then the corresponding side ratios will be the same. So what we have here is CE over DB will be equal to CE over DE is equal to AE over BE. Okay, let's plug into the numbers. AC is 6, AE is 3, BE is 4, ED is 8. Now we need to calculate CE and BD, right? Okay, we already know the side ratios is 3 to 4, right? So what a CE here would definitely be 6 because we want the ratios to be 3 over 4. At this one, 3 over 4, this one should be 8, right? So CE will be 6 and BD will be 8 for this one. Okay, this one is simple because you can directly know which two triangles are similar, right? Okay, it's given there. Okay, why don't you take a look at this one? This one. Okay. Oh, this one? Actually, look at here. We have QPS. QP, QPS. This one is marked here, the angle X. And this one is also marked here. Those two angles are the same. And we also have this, those two angles are the same. Okay. Now, when you first look at this one, okay, now we have two angles are the same. We could definitely prove, okay, those two triangles are similar. Wait a second. Look at here. Look at the blue angles. This one, and this R here. They're not even in one triangle, right? They're in different triangles, right? And okay, the red one, okay, they're in the same triangles, right? So this one actually give you the hand, right? So what we do here is, as long as you know, okay, the two x angles are the same. This one is equal to the top x angles. Okay, just do the sum with this one. What I mean here is this blue one, this blue angle, it will be the same as this one, right? The degrees will be the same because you're using the x plus the same part, right? Plus the common part. So those are actually the same. Now you actually put everything inside of two triangles, the triangle PQR and the triangle PST here. The PST will be this one. And the PQR will be this one. Right? Now we have two triangles that are similar. We actually proved this. So the side ratios will be the same. You don't even need to check on the graph. You can directly pick, okay, now I pick the first two over the first two over PS will be equal to the QR over ST equal to PR over PT, right? And PT over PT over ST, PT over ST is 324. Now we want to calculate QR over PR. Okay, now take a look at this one. Take a look at this one. The only difference is you can just switch the positions with those two. So QR over PR will be equal to ST over PT. QR over PR is what we need to calculate. And ST over PT is just the reciprocal of the given information, right? It's just 1 over PT over ST. It's equal to 1 over 3 to 4 will be equal to 4 over 3 or 4 to 3 if you want to represent in ratios. Okay. Any questions? Okay. That's the first way we prove two triangles are similar, right? And the second way is for this one, if you want to prove two triangles are similar, you have to know, okay, the angles information has to be given. What about we don't know the angles? We only know the side length. We can also prove two triangles are similar. Okay, how do we prove that? Is all the three corresponding side are in proportion, or the ratios are the same. The side ratios, the corresponding side ratios are the same. Take a look at this graph. The ABC and DF, the shape are the same, and the only difference is the size. So if we have AB over DE, okay, equal to AC over DF, equal to BC over EF. Okay, all the three sides are equal. So we prove two triangles are similar. Okay, let's take a example. Take a look at example. Now, I already marked the side length for those two triangles. Okay, if you do the ratios, do the ratio of the side. Okay, 17 over 8.5. And another one is 18.4 over 9.2. And the last one will be 11.6 over 5.8. Okay, this one is actually 2, right? This one is also 2. If you calculate the values, this one is also 2. So the three sides, you calculate the side ratios is the same. The ratio is always be 2. So we say, okay, those two triangles are similar. So my question now becomes, so in angles, we don't need 3A. We don't need angles to prove two triangles are similar, right? Because if two angles are determined, if two angles are given, then the third angle will be determined, right? There's only one possible values for the third angles. So we actually need to find two angles, two corresponding angles are the same. Then we can prove two triangles are similar. Now my question is, can we use side and side? Okay, same as, it's very similar to the angles, right? So I just pick two side ratios. It's the same. Can we prove this one is similar? Okay, you can put your answers on the blank. You can just put a Y or N to represent yes or no on the blank. Or you can also say, okay, it depends or something else. Okay. Okay. We have yes, we have no. Okay. The ratios will be have to have. Okay. Now, why don't we just using one example? Let's see at first the triangle I draw here is an equilateral triangle. Okay, the side length is 3. Okay. It's a perfect equilateral triangle. Like here. I draw here the triangle ABC here. Okay. Now the second one is triangle DEF. Now the special part for DEF is DE is equal to 6. EF, DF is equal to 6. Now if you calculate the ratios, DE over AB is equal to 2. Is also equal to DF over AC. The two corresponding sides, the ratios are the same. Okay, now DEF. Okay, if I draw another equilateral, okay, those two will definitely be similar. But wait, I can also draw like this. 6, 6, and this one, for example, is 11. Like this, or this one is 10. So it's not a right triangle anymore. Not equilateral triangle anymore. Okay, take a look at this one. DEF. This one is not similar to the triangle ABC anymore. But the two corresponding sides, if you do the ratios, it's actually the same, right? Okay. Now why is that? Is because the included angles are not the same, right? Look at here. This one, the angle A here, this one is 60 degrees. And this one, as long as the two side length is 6, this one could be anyone, right? I could also draw this. This is not. I could also draw like this, right? It could be any triangles as long as the two side length is 6, right? So only using S and S cannot prove similarity. Okay, so if the given information is, okay, DE over AB is equal to DF over AC, then we cannot say the triangle ABC is similar to triangle DEF. We cannot prove that. Okay, now let's take take a look at one example here. Okay, now for this one, okay, we have two right triangles. Okay, the only given information is two side length. The first one, let's mark here is ABC here. The second one, let's mark by DEF. Now the question becomes, how can we using the SSS similarity to prove those two triangles are similar? Okay, so the thing here is, okay, now, even though the given information are two sides, not three sides, not all the three sides, we can actually calculate the third one, right? Because this one is a right triangles, right? For example, the triangle ABC. We can get the side length for EC is equal to, according to the Pythagorean theorem, is equal to 15 squared minus 12 squared. This is based on Pythagorean theorem, A, B, C. In right triangles, we have A squared plus B squared equal to C squared. Okay. And if you calculate this one, it's equal to is this one, 15 squared minus 12 squared is equal to 225 minus 144. It's equal to square root of 81 is equal to 9 here. Okay, so this one, side length is 9. And this one, the DF in triangle DEF. Okay, so DF will be equal to 45 squared minus 36 squared. And if you actually calculate this one, it's equal to square root of 729. Is this one is actually a perfect square. It's equal to 27. Okay, now let's do the side ratios. Okay, 45 over 15 and 36 over 12, 27 over 9. Okay, the ratios is 3, right? So we actually prove, okay, it's still similar. Even though only two sides are given, it's not all the three sides are already given here. So, and from this question, you can also notice for a right triangle, we can using S and S, or in some textbook, we mark this one as H and L, the hypotenuse and the right legs. If you know two side ratios are the same, for right triangle, is similar. If it's not right triangles, it's not. Okay, so this is one special part for SSS proof for right triangles. Okay, any questions? Okay, now all the things we have here is, even though in right triangles you actually calculate like this one, we actually calculate the third side. We calculate the ratios. Oh, okay, that's actually the same. So we prove, okay, three angles are the same. We prove it's similar. Three sides are the same. We prove it's similar. What about all the given information here is it's not a right triangle. All we know here is the side ratios, two side ratios are the same. How do we prove this? Is, remember what I said here. The reason why we cannot directly using S and S to prove two triangles are similar is because the included angles could be different. But what about it's not different? Take a look at this one. The ABC, triangle ABC, and the triangle DEF. Okay, now the given information here is AB over D is equal to AC over DF. Okay, the two corresponding sides are the ratios are the same. Okay, and we have one more condition here is the included angles. Okay, this is a very important. The included angles are the same. Angle A and angle D. Okay, are the same. Then we can say, okay, the triangle ABC. The triangle ABC is similar to triangle DEF. Okay, it's not if you pick two corresponding sides, the ratios are the same, and then any one angles are the same, then you actually prove two triangles are similar. It's not. It's the included angles are the same. Okay. For example, if the given informations here is this one, AC over DF is equal to AB over DE. And another information here is angle B is equal to angle E. Okay. It's not angle A equal to angle D anymore. It's angle B equal to angle E here. Then you cannot get this one. Only the included angles are the same. We can see, okay, the two triangles are actually similar. Okay. Any questions? Okay. Let's take a look at one example here. Okay. Now we have triangle ABC and triangle DEF. Okay. If we want to prove, okay, those two triangles are similar. So now we can do, first we do the side ratios AB over DE. This one is equal to 17 over 8.5 is equal to 2. And we can also do AC over DF is equal to 11.6 over 5.8. This one is also equal to 2. Okay, now we have put them together. These two are the same. Okay, now we already have two corresponding side ratios are the same. The only one thing we need is the included angles are the same. So angle A is equal to angle D. So we actually prove based on the SES. We put the A, the angle between the two S, to make you understand, okay, this angle is not random angle, it's the included angles. Okay, we actually prove the triangle ABC is similar to triangle DEF. Okay, why don't we do a small practice? This one. Enlarge this one. No, X is not marked here, right? This one is X. This angle. Okay. To find the value for x, now two triangles are given here. Okay, now for triangle ABC, we only know one angle. All the information we hear is angle B here is 30 degrees. So it will be hard to directly get the x values, right? Because we don't know the angles for the degrees for angle C. So you cannot, okay, directly do 180 minus 30 minus angle C. But we actually have another one here. And for this triangle PQR here, for this triangle, two angles are given. So this one, the Q here is we can calculate 180 minus 58 minus 30 is 180 minus 88. It's actually equal to 92 degrees. Okay, now if we can prove those two triangles are similar, then we actually can get the values for x, right? Because for similar triangles, the corresponding angles are the same. Okay, now the question will become, how do we prove those two triangles are similar? Okay, two sides is already given here. So if we do PR over BC is equal to 7 over 3.5 is equal to 2. And if we do uh, this PQ over, uh, let's see, BA is equal to 6 over 3 is equal to 2. Okay, now the corresponding side, the two corresponding side ratios are the same. Okay, and we also have this included angles. Look at here. The two sides are the the green sides and the black sides. And the included angles are actually angle B and angle P here. They're both 30 degrees. So we can actually prove the two triangles are similar. The triangle PQR is similar to triangle BAC here. Okay, and the X is actually angle A and will be equal to the angle Q here is actually 92 degrees for this one, right? Okay, so this one, we prove two triangles are similar based on the side SAS. Then we got the values for the X based on the similar triangles PQR. Okay. Any questions? Okay, let's look at another one. This one. First, let's do the second questions because it's already given here. The two triangles are similar. Okay, AD is 4. BD is, let me just, let's do the second question first. But actually, you need to think about, okay, how do we prove the two triangles are similar? For triangle ADE and triangle ACB here. How do we prove those two triangles are similar? Okay, if you take a look at the ADE and the large ACB here, those two triangles, they share the common angle A here. And if you do the side ratios AE over AB, this one is 6 over AB is AD plus BD is equal to 15, where you write as 4 plus 11. So simplify this will be 2 over 5. And if you do another one for 80 over AC is 4 over 6 plus 10, plus 4 is 4 over 10 is 2 over 5. Okay. The two corresponding side ratios are the same, and the included angles are the same. So we actually prove those two triangles are similar. Okay, now, once you prove two triangles are similar, then the second one will be pretty easy. Look at here. ABC is 40 degrees. We need to calculate the angles for AED. Okay, now, you don't even need to take a look at the graph. Look at here. A, E, D. We take the first letter, third letter, and then the second letter. It will be equal to A, B, C here. We take it first, we take a look at the similar triangles. We take it first letter, third letter, and then second letter. It's equal to angle ABC here is equal to 40 degrees. Okay. And this one is also the same. So we do the DE over BC, or 7 over BC, is equal to 80 over AC. 80 is 4. EC is 10, 2 over 5. So for this one, is BC is actually equal to 35 over 2, equal to 17.5 for this one. Okay. Okay. Now, so far, we already know all the three methods to prove two triangles are similar. Now, based on okay, now you might think, why do we need to learn this? So this actually, I don't even know how to use this. This one actually are just concept, and it's just useless. But once you prove two triangles are similar, what we have here is, okay, look at here. If we have two similar triangles, then not only their angles on the side and the sides share a relation, but also their perimeters, their altitude, their angle bisector, their area, and other aspects are in ratios too. And because the limits time, I will talk about this in the next slide. But for now, I'll just give you some informations. For example, if we have triangle ABC and triangle DEF, if we know those two triangles are similar, and we know the side ratios is hold on, DF BC over EF equal to AC over DF. Let's say it's equal to 3. The side ratios is equal to 3. Then we directly know the perimeter for triangle ABC over the perimeter of triangle DEF will be equal to 3. The area of triangle ABC over the area of triangle DEF is equal to 3 squared. It's equal to 9 here. Okay, so I don't even need to calculate what is the area for triangle ABC. As long as I know the side ratios is 3. Okay, the area ratios will be the side ratio squared. The perimeter ratios will be equal to the side ratios. Okay, and this one will actually accelerate your calculating speed for geometry questions. Okay, but before we do this, you definitely need to get familiar about, okay, how do we know or how do we prove two triangles are similar? Okay. Okay. I think that will be all the information for today's class. So if you still have questions, you're welcome to sit and ask. Otherwise, I will call it for today. Thank you, guys. Bye-bye.
Thank you. Bye.
Okay. Bye.